Okay, students. Now I'm going to start the class. You listen very carefully. And today we are going to continue the atoms chapter and some more points I will explain regarding the Rutherford alpha scattering experiment. And is it my voice? And the board is appearing clearly right now. Okay, then I am going to continue now. You listen very carefully. Right? Is it clear, students? Voice and picture. Okay, the board is appearing now. Is there any problem, students? Is there any problem? No, no. Okay. Right. Thank you, Latika. Right. I'm going to start. And that is today's topic is the impact parameter. What is impact parameter? We know Rutherford alpha scattering experiment. In the Rutherford alpha scattering experiment, we are taking a gold foil. This is a gold nucleus, gold atom. Okay. According to the Rutherford, the nucleus, most of the positive charge is concentrated at the center of the atom. That is called as a nucleus. Most of the positive charge concentrate at the center of the atom. This point size is the, you see the, you follow the arrow mark. This point size is the nucleus. This is the nucleus. Okay, it is the nucleus. And now here alpha particles are allowed to incident. This one, this is alpha particle and this is an alpha particle, this is an alpha particle. This black circle is the atom. In that this is point is the, okay, this point, black point at the center of the circle is the nucleus. It's a point. Nucleus size is very much less than the atom size. You know, yesterday we discussed that the radius or the size of the atom is 10,000 to 1 lakh times of the size of the nucleus. If radius of the nucleus is 1 centimeter, then radius of the atom will be 10,000 to 1 lakh centimeters. Just it's an example. In centimeters, that measurements are not there because it is an invisible, very small particles. In angstroms, we have to measure. And now, what is an impact parameter? What is an alpha scattering? Let us discuss it here. Now, alpha rays are allowed to pass through one gold atom. Then what happens? Let us see. You see this line. This is the line, black line. Okay, it is passes through the center. Follow the arrow mark. If you have doubt, you can write in chat box. This is the line passing to the center of the nucleus, and this line is called as the central line. This line is called as the central line. Okay, and now alpha particle is allowed to incident along the central line. Central line is the line passing through the nucleus. Central line of the nucleus. It is the central line of nucleus. This is the central line of the nucleus. And now one alpha particle. Alpha particle means you know already. Alpha particle is what? What is alpha particle? Can anyone tell? What is alpha particle? Write in chat box. What is an alpha particle, students? What is an alpha particle? Write in the chat box. 2 helium 4. Doubly ionized helium atom is called as alpha particle. What is the charge of alpha particle? Plus 2e. Okay. What is the mass of the alpha particle? 4 units. Mass number we have to take. Why it is plus 2e? It is a double ionized helium atom. From the helium atom, if 2 electrons are removed, that is called as alpha particle. And the alpha particle is a positively charged alpha particle. That alpha particle is thrown along the center line. Then when the alpha particle is positive charge, it is going this side. You see the picture, arrow mark is going, alpha particle is going this side. And when the alpha particle is going this side, it is a positive charge, it is going this side. Here this point size is the nucleus, it is also positive charge. This is also positive charge. The nucleus charge we can take as plus ZE. Inside the nucleus, positive charged particles, protons are present. If Z protons are present, then its charge is plus ZE. This is the nucleus charge, and this is alpha particle positive charge. When alpha particle is allowed to travel along the central line, then this positive charge nucleus repels the positive charged alpha particle because like charges repel with each other. Due to the repulsion force, the velocity of the alpha particle decreases, and finally velocity becomes 0. At this point, the velocity of alpha particle becomes 0. But here, due to the repulsion force, it will start to go back. Okay, it will start to go back. That means how much angle it is deviated, what is the scattering angle in this case. Okay, that is said to be head-on collision. That is said to be head-on collision. Okay, in head-on collision means if the collision is occurred between the alpha particle and the nucleus face to face, like this. This is an alpha particle, okay, and this is the nucleus. Then the face to face collision is said to be, right, head-on collision. In case of head-on collision, what happening? Okay, in case of head-on collision, how much angle of scattering is there? What is the angle of scattering? Angle of scattering means it is the angle between the scattered alpha particle and incident alpha particle. Incident alpha particle is going right side firstly in the figure, and then after the scattering, due to the repulsion, it will come back after traveling certain distance. This is the initial direction, this is the final direction. How much angle it is rotated? Like this, it is rotated, right? This is the initial direction, this is the final direction. How much angle it is rotated? It is rotated, right? आगे जाने वाला पीछे जा रहा है. The alpha particle initially trying to move right side, then it will be deflect and goes to the left side. That means how much angle it is deflected? In case of head-on collision, scattering angle is the 180 degree. Scattering angle is the 180 degree. Here, what we are asking it here, we are writing the heading impact parameter. What is an impact parameter? Before going to discuss this impact parameter, we have to know this is the first alpha particle which is incident along the center line. Another alpha particle which is little bit far away from the center line. You see, it is at b distance. Okay, and this at this distance, little bit far away from the central line. This is the central line. Okay, and it is passes through the center of the nucleus. This alpha particle which is incident along this, it can go back like this because of large repulsion, because it is very coming close to the nucleus. That's why it will go like this. And then this alpha particle will be deviate and it will go like this, and this alpha particle will go in the straight. This alpha particle which is incidenting, why it is going in the straight? Because this alpha particle is at far away from the nucleus. That's why the nucleus repulsion force is very less. Okay, nucleus repulsion force is very less. That's why it will go in the straight. These alpha, all alpha particles will go in the straight. Okay, you see here, that means the alpha particle which is incident, which is passing near to the nucleus, it will be bends more because of more repulsion force. If distance is less, then the repulsion force is more. You know, force proportional to 1 by 4 pi epsilon, force formula 1 by 4 pi epsilon into q1 q2 by r square. Force is inversely proportional to distance square. If distance is less, force is more. Here alpha particle which is passing near to the nucleus, it can deviate more. The alpha particle which is passes far away from the nucleus, then it can go in the straight. That thing happens at here. What is impact parameter? This is the initial velocity of alpha particle. For example, this is an alpha particle. It is thrown like this. This is the initial velocity of alpha particle. The initial velocity of alpha particle, and this is the center line. You see here, this line is the center line. The perpendicular distance of, for example, this is the central line of the nucleus. This is the nucleus, and the alpha particle is incidenting like this. This is the initial velocity of alpha particle. The perpendicular distance of initial velocity vector, the perpendicular distance of initial velocity vector from the center line is called as the impact parameter. This is the impact parameter. Impact parameter is the distance of initial velocity vector. This one, u distance, initial velocity like this there, alpha particle, right? And its distance from the central line is called as the impact parameter. For example, in this, if in case of for example 1 alpha particles, 2, 3, 4, there are 4 alpha particles. In case of first alpha particle, this is the central line, right? Then first alpha particle distance from the central line is less, impact parameter is less. Impact parameter is nothing but distance of initial velocity of alpha particle. Initial velocity of this alpha particle is this side, and its perpendicular distance from the center line is b. Right here b is less, but for the last alpha particle, fourth alpha particle, its initial velocity distance from the central line is more, right? That means when you will go away from the central line, the impact parameter is increases. Are you understanding, students? Is it clear? If you have, you can. If you have doubt, you can write in the chat box. Okay. In case of head-on collision, what happens? In case of head-on collision means direct collision. Like this, it will be there. Okay. This is an alpha particle. It will be travel like this. Initial velocity vector, and this is the nucleus. Okay. This is the nucleus, and now this collision, this thrown along the center line. This is the head-on collision. In this case, what happening? Alpha particle is coming back after going to a certain distance. Is it right? Alpha particle coming back after going to certain distance. Then how much angle of scattering is there and impact parameter is there. In this case, in case of head-on collision, impact parameter is impact parameter impact parameter is 0. Why? Why impact parameter is 0? Because impact parameter is the distance of initial velocity vector from center line. This is only central line, that is only initial velocity. In case of head-on collision, that's will be 0. In this case, angle of scattering is how much? Then angle of scattering is then angle of scattering is 180 degree. How much? 180 degree. Have you understood why how it is 180 degree? Because initially it is going right side and finally it will come to left side. That's why uh, angle between the initial direction and final direction is 180 degree. That is the angle of scattering. Okay. In case of undeviated alpha particle, you see undeviated alpha particle. In case of undeviated alpha particle, in case of undeviated alpha particle, undeviated alpha particle is what? This is undeviated alpha particle goes straight, right? This is also goes straight. Third alpha particle and fourth alpha particle goes straight without a deviation. Why they are going straight? Because they are very far away from the nucleus and they are not much repelled by the nucleus. The nucleus influence is less on the alpha particle. What happened? Nucleus applies the repulsive force on the alpha particle because alpha is positive, nucleus is also positive, but this ray is very far away from the nucleus. That's why influence is less, force is less. That's why it will go in the straight. In the This is undeviated alpha particle. In case of undeviated alpha particle, B is more, right? This B is maximum. B is the central line from central line distance. B is maximum, right? Impact parameter is maximum. And angle of scattering is how much? No scattering. That means angle of it is not bending. It is going in straight. That means it is not bending means angle of scattering become 0. Okay. Now in this case, in case of undeviated alpha particle, impact parameter is how much? Impact parameter is there? Impact parameter is maximum. Okay. But angle of scattering is minimum. Angle of scattering is minimum. Okay. Right. And how much angle of scattering will be there? Angle of scattering is nearly 0. It is not deviated. It is going in the straight. No scattering. Okay, till now, have you understood the concept? And if you have the doubt, you can ask me now. Okay, write in the chat box, students. Give the comment. Priya Mato, right? Distance from the central line. Which distance? Distance from the central line. Okay, but that is the initial velocity of alpha particle distance. Alpha particle traveling in some direction. Okay, alpha particle traveling like this, right? This is the initial velocity of alpha particle. Fourth alpha particle, its distance from central line is called as impact parameter. First alpha particle is this one. First alpha particle distance from central line is also called as, this is central line, also called as impact parameter. That means based on the alpha particle, right? Okay, impact parameter will be changes. When you will go away from the center line, distance will be increases. That is only impact parameter. Impact parameter is also increases, right? Okay, clear students? Can I erase? Right, I'm going to erase this. Take care. Take the screenshot and note it. But if you have doubts, you can ask me. Okay, don't hesitate to ask and motivate your friends to join in the class. Yesterday, so many members came to the class, but today the strength is again decreased. Yesterday, this impact parameter and angle of scattering. Explain the impact parameter and angle of scattering. Define impact parameter and angle of scattering. Derive the relation between them. It is a previous question. Okay. And now, next, let us go for the definition of angle of scattering. What is angle of scattering? It was very simple. You know about the angle of scattering and scattering. It is denoted with the theta. The angle of scattering definition is, that is, angle between the direction of incident alpha particle and scattered alpha particle. Angle between the direction of incident alpha particle and scattered alpha particle is called as angle of scattering. Angle of scattering. Okay, the angle of scattering. And now I will explain with the diagram what is angle of scattering. For example, alpha particle is going this side. This is the initial direction of the alpha particle. Okay, this is the initial direction of the alpha particle, but due to some reason its path is changed. Okay, and it is going this side. This is the final direction of the alpha particle. This alpha particle is the incident alpha particle. Okay, this is the incident alpha particle, and this direction is the incident direction. This is the incident alpha particle. Okay, and this is the scattered alpha particle is going this side. This alpha particle is the scattered one, and the angle between the incident and the scattered, this is the incident direction. Okay, incident is like this there, and after the scattering, after the bending, deviating from its original path, alpha particle is going this side, and the angle through which it will deviate from its original path, how much angle it is bending from its original path. Alpha particle is going in the straight like this original path, but it is deviated and travel this side, and this is called as the angle of scattering. And scattered alpha particle, okay, and incident alpha particle. Incident direction is this one, scattered direction is this one. Angle between the direction of incident alpha particle and scattered alpha particle is called as angle of scattering. Okay, and what is the relation between the angle of scattering and relation between relation between angle of scattering and impact parameter? What is the relation between them? Okay, right. Now let us discuss it here. That relation, that is, if angle of scattering is more, then impact parameter is less. Okay, that they are just like inversely proportional. If impact parameter is, if impact parameter is more, if impact parameter is more, then this is the relation. Previously also we discussed it. For the undeviated alpha particle, B is maximum, but theta is 0. Okay, theta B is maximum, theta is 0. Theta is 0 means minimum. Previously also we discussed. If impact parameter is more, then angle of scattering is less. Angle of scattering is less. And impact parameter is if impact parameter is less, then angle of scattering is more. Okay, it was very simple. Okay, if B less, theta more. If B less, then theta more. If B more, then theta less. Okay, right. Next one is I'm going to explain relation between the impact parameter and angle of scattering. There is one formula is there. You remember its derivation is not there. Okay, and that is impact parameter formula is 1 by 4 pi epsilon naught into Z e square cot theta by 2 by Ke. Okay, this is the relation between the B and theta. In this, Z means atomic number, B is the impact parameter we know, that is the atomic number, Ke is one term that I think you don't know. This is the kinetic energy of alpha particle. Very simple. It is the kinetic energy of alpha particle. Alpha particle initially thrown with some velocity, right? That is that kinetic energy. Kinetic energy of alpha particle is Ke, right? That is the atomic number of the target nucleus. Okay, that is the atomic number. Atomic number of target. That is the atomic number of target. That means alpha particle is projected towards a target atom. Its nucleus. That is the atomic number of target atom or the nucleus. Okay, right. Now, is it clear, students? If you have doubt, you can write in the comment box. And those who joined lately in the class, and everybody should give the attendance. Okay, so many students are not coming to the class. I am observing each and every students. Okay, I will see in the future what happening. Okay, let us go for the next class continuation. That is distance of closest approach. This is also important topic. If you have any query, okay, if you have any doubt, please write in the comment box. Don't hesitate. I'm ready to clarify your doubts. Distance of closest approach. Don't keep your doubts in the mind, and you 100% you should try to clarify your doubts. If you have any problem, then you have to tell me. Even if any voice problem or the writing problem or any other problem, because I'm doing the work for you, and if you're not satisfied, then my work is waste. That's why I'm asking many times. Is it clear, students? Okay, distance of closest approach is what? Okay, you see here, this is a alpha particle. You see, this is an alpha particle. I'm drawing one diagram for you. Right, this is an alpha particle. It's an alpha particle. What is the charge of alpha particle? Priyamato, write in comment. What is the charge of alpha particle? Alpha particle charge is what? This alpha particle is thrown towards the nucleus. For example, this is a nucleus. This is a nucleus. Its charge is plus Ze. Okay, Z is the atomic number. It is the nucleus. Now one alpha particle is thrown towards the nucleus. One alpha particle is thrown towards the nucleus. And this alpha particle is going, that's with initial kinetic energy I am throwing. That initial kinetic energy we can consider as Ke, that is equal to half mv square. That is the initial kinetic energy of alpha particle. When you throw this alpha particle this side, then what happens? This alpha particle goes that side. After traveling certain distance, while traveling right side, okay, due to repulsion force, due to the repulsion force, and its speed will be decreases because this atom repels the this atom repels this nucleus repels the alpha particle, because alpha particle is positive charge, nucleus also positive charge, they will be repel with each other. Slowly its velocity decrease. When it come to here, its kinetic energy becomes zero. Initially, for example, there are alpha particle and nucleus is very long distance. Potential energy, potential energy is also there, this charge potential energy, potential energy is also there, this charge q2 we will take, it is the nucleus charge is Ze, and alpha particle charge is q1, we can take, that is plus 2e. Then between them potential energy is also there. What is the formula for the potential energy between two charges? 1 by 4 pi epsilon naught q1 q2 by r. After coming to here, the kinetic energy becomes zero, but the potential energy is increases. Why potential energy is increases? Potential energy formula is 1 by 4 pi epsilon naught into q1 q2 by r. Whenever the alpha particle moves from here to here, its kinetic energy decreases. Then due to that distance between the atom and alpha particle is also decreases. When the alpha particle moves this side, the distance between this alpha particle and the atom is decreases because alpha particle is coming close to the nucleus. When the distance decreases, potential energy is increases. When it come to here, kinetic energy totally becomes zero, here velocity becomes zero, then that's where it will convert into total potential energy. And here, this is the closest position, this position is said to be closest position, and the closest position of distance of closest position of alpha particle from center of the nucleus is called as closest distance of closest approach. Distance of closest approach. From the figure, we write r naught is the distance of closest approach. Okay, what is closest approach? Distance of closest approach. From the figure, r naught is the distance of closest approach, and its definition and its explanation I am going to give now, and you listen very carefully. That is, first, when an alpha particle, when a alpha particle thrown towards gold nucleus, its kinetic energy decreases, and electrostatic potential energy increases. Electrostatic potential energy increases. At a particular at a particular at a particular position, kinetic energy of alpha particle, kinetic energy of alpha particle becomes zero. This occurs due to repulsive force, repulsive force between alpha particle and nucleus, right? What we are telling it here in this some explanation regarding this diagram I am giving. Alpha particle is thrown with certain kinetic energy. Okay, while moving towards the goal nucleus, what happens? Kinetic energy is decreases. Why kinetic energy is decreasing? Because of repulsion force. This nucleus repels this alpha particle. That's why its velocity decreases. At a particular position, the kinetic energy become zero. And but at that position, total kinetic energy converted into potential energy because the distance between when the alpha particle coming close to the nucleus, the distance between the alpha particle and nucleus is decreases. When distance decreases, potential energy automatically increases. That means whenever alpha particle thrown with certain kinetic energy, uh, whenever alpha particle is thrown with certain kinetic energy towards the nucleus, at that moment the kinetic energy is decreasing and that is converting into potential energy. And what is the definition of distance of closest approach? Okay, let us go for the definition actually. This definition is required for you. You should have the definition. A very easy definition. In the name only it is there. What is the distance of closest approach? Closest approach. This alpha particle is coming close to the nucleus up to here. This is the closest approach. Its distance, the closest position distance from the nucleus, right? Its definition is the distance of closest position. The distance of closest position of alpha particle. Closest position of alpha particle in the figure is this one. This is the closest position. From here, what happens? It will go back. Okay, this is the closest position. And this closest position distance, the distance of closest position of alpha particle from where? Okay, the distance of closest position of alpha particle at which kinetic energy becomes, at that closest position what happens, at which its kinetic energy becomes zero. Its kinetic energy at that closest position, kinetic energy becomes zero. That closest position is distance of closest position of alpha particle from where? From the center of the nucleus, right? Completed definition. Where is it? This is the closest position of alpha particle. You see the figure. This is the closest position of alpha particle. This position distance from the center of the nucleus is called as distance of closest approach. Is called as distance of closest approach. Very good. Are you understanding clearly? Right. It is denoted with what? R naught. Very good. Now let hear what happening. Kinetic energy of alpha particle convert into potential energy. Na? Kinetic energy converts into potential energy. Right? Potential energy. Electrostatic potential energy. Kinetic energy of alpha particle equal to electrostatic. Loss of kinetic energy of alpha particle appears in the form of electrostatic potential energy. Okay. And the kinetic energy is we can consider as the Ke. What is the formula for the potential energy? Potential energy formula is 1 by 4 pi epsilon naught into Q1 Q2 by R. Q1 is what? 2E. Q2 is what? ZE by distance between them is what? R naught. This is the formula for the potential energy. You know potential energy formula. U is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R. You know this formula? Very good. You know this formula we have to apply it here. I want the closest distance of closest approach of formula, right? Distance of closest approach is R naught. 1 by 4 pi epsilon naught Q1 alpha particle charge 2E, Q2 nucleus charge ZE. 1 by 4 pi epsilon naught Q1 Q2 by R square. R square means force will comes. Potential energy only R will comes. Okay. From this R naught formula I want. Then what you will get the R naught formula. You take the screenshot and note it, and if you have any query you can write in the chat box. Priya Mato asked one question. from where the alpha particle is scattering. Alpha particle is scattered by the target atom. Target atom is either gold atom or anything we have to take. Okay, right. And now I'm going to erase this. Right, you take the screenshot and note it. Next one. In this, what happening at here? uh, we want the R naught equation from previous one. What is the R naught? Very simple, 1 by 4 pi epsilon naught into, right? Previously in the equation here we wrote 2e into ZE. We will get 2ZE square by KE we will get. This formula we can also write like this. This is the distance of closest approach formula. Based on this, they may ask the problem. Okay, you have to try to understand each and every term in this. Okay, right. Now, what are the terms at here? Ke is the kinetic energy of alpha particle, right? Kinetic energy of alpha particle. And in this, m is what? Mass of alpha particle. Mass of alpha particle. What is v? Velocity of alpha particle. Velocity of alpha particle. What is z? Z is the atomic number of atom. Atomic number. Atomic number of target nucleus, which is the reason for the scattering. Okay, right. Generally gold atom, anything. E is the electron charge. E is the electron charge. You know what is the value of electron charge? That is the 1.6 into 10 to the power of minus 19 coulomb. And that is what completed. Epsilon naught is what? Permittivity of free space. What is the value of 1 by 4 pi epsilon naught? Its value is 9 into 10 to the power of 9 Newton meter square per coulomb square. You know this one. What is epsilon naught? Permittivity of free space. Okay, you take the screenshot. I'm going to start the next topic. Okay, till now is it clear, students? Students, is it clear? Have you any doubt, any query? You can ask me. Okay. Now I'm going to erase it. You listen very carefully. I'm going to continue the class. Right. Right. Now the next topic is it is a previous 3 marks question. Then derive expression for potential energy and kinetic energy of electron in hydrogen atom. Okay. And that is red heading potential. Is board is appearing clearly or not? Any problem? Potential and kinetic energy. Potential and kinetic energy of electron. Potential and kinetic energy of electron in hydrogen atom. Okay, potential and kinetic energy of electron in hydrogen atom. This is our topic, very important. Okay, previous also distance the 3 points. Today lecture is totally important. Distance of closest approach, impact parameter, angle of scattering, everything is important. Okay, now let us see here what we are going to do. Potential energy and kinetic energy of electron in hydrogen atom we are going to discuss. In hydrogen atom, how many electrons are there? Okay, one electron will be there. Right? In hydrogen atom, there is an electrostatic force between the nucleus and electron that serves as centripetal force. In hydrogen atom, electrostatic force electrostatic force between between nucleus and electron. Nucleus and electron serves as centripetal force. That will serve as centripetal force. What happening it here? This is the nucleus. Okay, in the hydrogen atom, this is the nucleus. How many protons are there in the nucleus? Only one proton. Charge is plus 1e. And now one electron revolves around the nucleus, right? For example, this is the nuclear orbit. In that orbit, one electron will revolves. This is the nucleus. Its charge is plus 1e. And this is considered as one electron. This is an electron. And this electron is going with speed v. And electron mass is m. It is moving along a circle, along a particular orbit. This is an orbit. And now the distance, the radius of the orbit we can consider as r. Okay, electron is revolving. Electron revolve around the nucleus in particular orbits. Electron revolve around the nucleus in particular orbits. During that, okay, this is the nucleus. Nucleus consists revolve in the particular orbit, but electron is in circular motion. To maintain any body in the circular motion, centripetal force is required. Who is providing the centripetal force? This positive charged nucleus attracts the negative charged electron towards its nucleus, towards center. That force is called as the centripetal force. Which one serves as the centripetal force? Can you tell? Who is acting as centripetal force? That electrostatic force. Electrostatic force between the nucleus and electron. This is the nucleus, this is the electron. Will serve as centripetal force. Centripetal force is necessary to maintain any body in circular path. What is the formula for the centripetal force? mv square by r. What is the formula for the electrostatic force? 1 by 4 pi epsilon naught into q1, q2 we have to write. q1 is plus 1e and q2 is minus 1e, but electron charge, but we should not take the minus. We should take up 1e into e only. Okay, proton and electron. And distance force formula is what? Coulomb's law. 1 by 4 pi epsilon naught q1 q2 by r square. Now we have to cancel something, right? You see very carefully. This r and this square will cancel, and then the next step what will remains? Next step will remain as mv square is equal to, we will get on the right side, we have to multiply. Any doubt in any step you can ask me. Okay, e square by 4 pi epsilon naught v r we have to write, and then after that you have to multiply with half on both sides. Multiply with 1 by 2 on both sides. Okay, right. Then what happens? Half mv square is equal to, we will get as half into e square by 4 pi epsilon naught r we will get. Now half mv square is the kinetic energy. The kinetic energy formula we will get as 8 pi epsilon naught r. This is the kinetic energy formula. Okay, right. And r is what in this? R is the radius of orbit. Okay, radius of orbit. M is the mass of electron, and v is the speed of electron, and ke is the half mv square, kinetic energy of electron. This is the speed of electron. It is the speed of electron. Okay, right. We got the kinetic energy. Next I want the potential energy, right? We derived the kinetic energy. The next I am going to derive the formula for the potential energy. What is the potential energy of electron? Potential energy of electron. Oh, one point I have to write it here actually. That is the kinetic note. That is the kinetic energy is always positive. You remember that. Negative kinetic energy is not there. Kinetic energy is always positive. You don't take the kinetic energy as negative. No, there is no body which has negative kinetic energy. The potential energy may be negative. Okay, I'm going to erase. Next I am going to derive the potential energy formula. Okay, I will write here only. Potential energy of electron in hydrogen atom. Potential energy of electron in hydrogen atom. Right? What is the potential energy of electron in hydrogen atom? Potential energy formula is what? Previously, you know, potential energy formula is 1 by 4 pi epsilon naught into Q1 Q2 by R. Okay, right. Then here the potential energy we will get as P is equal to 1 by 4 pi epsilon naught into Q1 is the nucleus charge plus 1e and Q2 is the minus 1e. Here you must take the negative sign. Okay, why? Because the potential energy is negative also. Next, I'm going to erase this and you take the screenshot and note it. Otherwise, I will continue like this. It's a continuation, I will tell. And now, okay, let us see here. Mm, I will draw with different color. Note it very carefully. Now I am going to continue, right? Now I wrote the last equation is this one. Its equation continuation I am going to do. That is the potential energy is equal to what you are getting here 1 by 4 pi epsilon naught into this 1e into minus 1e. We will get minus e square by r. We will get. Then the potential energy formula we will get as minus e square by 4 pi epsilon naught r. This is the potential energy. Okay, we derived the potential energy and kinetic energy formula. Next, I want to derive the total energy also. Okay, and the total energy of electron in hydrogen atom. Energy of electron which is revolving around the nucleus in the hydrogen atom. Total energy of electron in hydrogen atom. What is the total energy of electron? The total energy is nothing but, it was very simple, you listen. Total energy means just we have to add the two energies. That is the total energy is equal to sum of potential energy and kinetic energy. That is the total energy we write as E is equal to potential energy plus kinetic energy. Then E is equal to potential energy is what here? Minus E square by 4 pi epsilon naught R plus kinetic energy is E square by 8 pi epsilon naught R. Now we have to do the LCM. LCM you will get as 8 pi epsilon naught R and then minus 2E square plus you will get here 2 and plus 1E square you will get. And final formula you will get is minus 2E square plus 1E square is a minus E square by 8 pi epsilon naught R. And the total energy formula is minus E square by 8 pi epsilon naught R. This is the formula for the total energy. Okay, right. This is the what? Kinetic energy formula we derived it here. And here we derived the potential energy formula. And here we derived the total energy formula. but the total energy you got is negative. What is the meaning of that? Total energy is negative, indicates that total energy negative indicates right. Let us see here. Oh, there is a flexibility option. Till now I am not used it. The board is very lengthy. If you want, we can use that one. Now I'm going to continue now. That is here we got the total energy. You see in the last equation, right? And the total energy is negative. What is the meaning of this one? Total energy negative indicates what? Total energy is negative. Okay. Total energy of electron. Total energy of electron is negative. This gives that electron bound to the nucleus. Electron bound to the nucleus. Electron is not allowed to escape from the nucleus. That's why electron has negative energy. If electron has positive energy, then it will escape from the nucleus. Okay, if you throw any object, then you are giving the positive energy for that. If any object is having the positive energy, then it can escape. For example, you have a stone in your hand, but you thrown, not thrown, just release it. At that moment, it has the negative energy of the ground. Due to that, it will fall on the ground. Okay, similarly, the electron has negative energy because it is under the attraction of under the it shows that the electron is under the nucleus attraction. It is not allowed to escape. I want the relation between the potential energy, kinetic energy, and total energy. For that, I can write like this from equation 1, 2, and 3. What we can write? That is the potential energy we write as what firstly we derived the kinetic energy formula. What is the kinetic energy formula that you got here? The kinetic energy formula you got is E square by 8 pi epsilon r. And what is the potential energy formula? Potential energy formula you got is minus E square by 4 pi epsilon naught r. And what is the total energy formula that you got? Total energy TE is equal to you got is minus E square by 8 pi epsilon naught r. Okay, right. From these equations, we write one thing. What is the relation between the total energy and kinetic energy? What is the relation between the total energy and potential energy that I want? From above equations. Okay, total energy is equal to, you see the total energy formula, minus E square by 8 pi epsilon naught, minus we can keep aside, remaining is what? E square by 8 pi epsilon naught r, it is the kinetic energy. Can we write like this? Total energy equal to minus of kinetic energy. Why? Because you see here total energy is minus E square by 8 pi epsilon naught r, minus keep aside and remaining E square by 8 pi epsilon naught r is the kinetic energy, then we write minus kinetic energy. Next, I want the relation between the total energy and potential energy. This is the relation between the total energy and kinetic energy. I want the relation between the total energy and potential energy. Further, what we have to do here, you see here potential energy, then what you have to do in order to convert that into total energy, if this potential energy is divided with 2, okay, by 2, you multiply with 1 by 2, potential energy multiply with 1 by 2, you will get this total energy. The means total energy is equal to 1 by 2 of potential energy, right? Why? You multiply with half at here, 1 by 2, p is multiplied with half, minus E square by half means 2 into 4, 8, you will get minus E square by 8 pi epsilon r, you will get means total energy you will get, means if potential energy is multiplied with half, you will get the total energy, right? That means total energy is half of the potential energy. I want the relation between the kinetic energy and potential energy also. For example, if kinetic energy is potential energy is multiplied with minus half. Okay, then what happens? You will get the kinetic energy. Derived from above equations, kinetic energy is equal to half minus half of the potential energy. These are the some relations that we got from here. Okay, is it clear, students? Any doubt? Or is it for any atom or hydrogen only? This is we derived for only hydrogen atom. Uh, yes, electrostatic force only act as a centripetal force. Electrostatic force means positive charged nucleus attracts the negative charged electron. Positive charged nucleus attracts the negative charged electron. You see here, you take the screenshots. Okay. Yes, this is the beginning. You see, this is the positive charged nucleus that is attracting the negative charged electron which is moving in the circle. That attraction force serves as a centripetal force. Because to maintain any body in the circular path, the necessary force is the centripetal force. Without centripetal force, no one will move in the circular path. That's why the centripetal force will serve as electrostatic force. This is we derived for only potential energy, kinetic energy, total energy. We derived for only hydrogen atom. Why? Because here we took the nucleus charge as only plus 1e. Why nucleus charge is plus 1e? In case of hydrogen atom, only one proton is there in the nucleus. One proton charge is plus 1e. And electron charge is e. Only one electron is there in the hydrogen atom. That's why we wrote e. Okay, these values we wrote for only hydrogen atom. For other atom also we can derive in the next class. Okay, right. Is it clear, students? And any doubts now? If you want, you can ask. And next topic is very important. More 3 days required to complete this chapter. Okay, your cooperation is required, and every day class is required. More 10 days. You motivate your students. Okay, 12 marks. If you will come 10 days regularly, then you will get the 12 marks. Only 10 days continuously you can come. 10 days, within 10 days I will close the syllabus. Okay, and for the next two chapters are pending. Nucleus required the 3 periods, 3 hours, and next semiconductors required the 5. Semiconductors requires 5 periods, and one more is nucleus required 3 periods, semiconductor required 8 periods, and more 2 periods or 3 periods required for this chapter. Okay, thank you to all. I am going to close.